All right. Hey, everyone. Another deep dive time. So this time we have on with us David from Autonolas. I met David out in Lisbon, right?
Yeah,
And
that's right.
yeah, it was a great conference, and he's building something pretty cool. So definitely want to have him on. So yeah, tell us, I mean, how did you get into building? I mean, what would you call this protocol? Would you call it it's off-chain computation, I guess you could say? Or
I think, yeah, that's a sort of one way to put it, and it's definitely a correct way. Um, if you want to be grand for a moment, what our North Star is helping DAOs become co-owned AIs.
Oh
Um,
man, that's yeah.
so gotta throw the AI in there from the start. No, but like off-chain compute is sort of the practical side of things.
Yeah, how did you get into kind of building this? What was this? What was the story here?
So early 2019, I was seriously looking to get into crypto, and at the time I started at the startup called Fetch AI, and they kind of had these ambitions to kind of use autonomous agents. And that's where it all started. It would be a very long story. We can dive into it in parts for sure, but like sort of, I don't want to bore with the details. I think that the high level of it is that at the time, autonomous agents, this kind of software which is underlying all the things we do at Autonolas, had like sort of one big unlock, which was like smart contract blockchains. And I kind of saw that giving rise to a lot of the applications Fetch AI was thinking about, but also being very relevant for DAOs. But it really got exciting this year with like LLMs, or late last year, which is sort of like better thinking tools for autonomous agents.
Yeah, I mean,
And
what was
so
yeah.
there's this whole arc, which kind of starts there and ends here and continues hopefully.
Like, I mean, I guess like when you started this in 2020, like just for a background for people, what is or sort of was or is the background of like how many people what's the current state of like AI and blockchain, and like where are people actually using this in any capacity, and how to like what was
Yes.
going on?
So there's a couple of questions, right? So in terms of like autonomous, are people using it? Yes. Like we should talk about some of the use
Right.
cases. And then in terms of this intersection, crypto and AI, I think it's very nascent. Like I think I can say that I've been at that intersection for since the whole time I'm in crypto, because like multi-agent systems is a subset of AI. But obviously there's like many areas of AI, and so like now you get like a lot of attention for ZKML. There's the kind of autonomous agent stuff which really blowing up this year. There's other forms of AI at the intersection of crypto.
Cool. Well, yeah, let's just kind of deep dive in how it actually works, and then we'll ask a whole bunch of questions kind of along the way.
Let's do it.
I'm gonna pin myself so that people can see the whiteboard a little bit easier. Okay, so what's your go-to example for a user? Like, is it, I
Yeah,
know you guys do oracles, is it something different?
I think let's start with the sort of more boring use
Sure.
cases, which are very kind of known. So Oracle is one, Keeper is another. So an oracle, right? We have like a set of off-chain nodes. So
Well,
we
so
can like,
yeah, well, I mean, we can start here. So this will be our user guy. This would be, I guess, what he could be like a trader or
hence for Oracle, it tends to be on-chain
okay, so this will
protocols,
be
right?
yeah, so he'll be
A smart
a
contract.
stable coin smart contract. Uh, he'll be a stable coin, and he wants the price of ETH US dollar into a smart contract.
For instance, yeah.
Okay. So
So that
then
would be on-chain. And so we
this
need to get that information from off-chain, because they've said, well, there's on-chain information about these pairs as well, but it tends to be that people also
you
want
could
to
say it's
have.
Bitcoin USD. We'll do a pair that's not
Okay,
on.
exactly. exactly. And then people want to have that information from the off-chain world. And so you could build this on autonolas, and we have use cases which are implemented as demos. We don't actually have like anyone using our oracles. We have a lot of people using our keepers. But I
it works the same way, right?
Exactly. It works the same way. So you have like a set of nodes off chain. That's do for.
So this would be like we'll write over here. This will be the autonomous smart contract, right? This will be your autonomous smart contract, and then you have a bunch of nodes. I guess these are, what do you call them? Nodes or?
So we actually call them agents,
Agents.
but people know the terminology of nodes. So
agents. Okay, and then are these guys staked? How do you become an agent?
exactly. So there's the actual code which an agent is made of, and then there's the operator of that agent. So the operator of the agent, so I guess like this little person there is the actual agent code. And then the operator would be, for instance, you or a group of people, one each operating one of those nodes or agents.
Okay, so this guy would post some code here, right?
We'll come to that in a second. I'm still talking about the off-chain part. So I'm just talking about the node operators, basically. So these are like, someone has to run that code off-chain. It's like machines living in different parts of the network, like the internet. Some might live on like someone's AWS account, some might live on someone's local setup, and they form a network off-chain, and they communicate to each other observation of price. And once the majority of them agree, they will then send that price to a smart contract on chain. And from there, it's accessible to our end user smart contract.
Right. So I guess this guy, well, I mean, what would he put in? He would go to your smart contract and he would say like, I want the median of these 5 APIs, right? That would be what he would say.
There's different models. So you can have a request response model. So Chainlink does it that way, or you can like have like more the kind of, actually Chainlink does both. You can also have a price feed, right? Where it just continuously does that based on some conditions, either like literally on like some time frame, like number of blocks or clock time, or you could have things where.
But I mean, how would he kick that off with the agents? Like, how would he get them to start reporting the price of Bitcoin US dollar? Would that be negotiated off chain, or would that be something that you?
In the oracles which we have live, it's basically a continuous price feed. So at every interval, it will update the price. But that kind of request response model, which you're referring to, it's obviously also widely, and I think you guys are using that, right, at Trello.
Yeah, well, it's just like how would you do it obviously, like if you want a new price, how would you get these guys to do it? You would probably just go off chain and call autonomous and say like, can you guys start posting this one?
So they do this in this application I'm referring to. They do it continuously, autonomously. So at every interval, so every, I think, half hour, whatever it is, they will kind of look at the different centralized exchanges which they're monitoring. They aggregate that information. They then sign it collectively. And then one of them sends a transaction on chain to deliver it on chain. And then from that point onward, it can be consumed on chain.
And these guys you said these guys are staked, right? So there's like.
Yes. So in autonolas, the system allows you to use ETH or ERC20s as the staking medium.
Oh, so this guy over there, the user would say what the stake is?
No, so the operators would provide the stake, and the service owner, it's like basically the entity who cares about this particular autonomous service. They would be specifying what the staking medium is. So let's say in this example, because as I said, the Oracle is not a product anyone uses, it's just a demo. We are like Valerie, the company who's building mostly autonomous, we're kind of the service operator. And so we
So that would be like
basically
the smart
specify the
contract
state.
here. You would specify like this is going to be the Oracle contract. Okay, now I get it. And then you would say like, and you have to stake 10 ETH per person. And then when you sign it, you put it in.
Exactly. So that's generally the model. So
Okay.
basically the security model is similar, or the threat model is similar to what you have in a sovereign proof of stake chain.
Yep.
Where you have like sort of the assumption that there's an honest majority of node. But outside that honest majority, nodes can be malicious even, and the system will function.
And then what is the slashing mechanism? Would that be the operator gets to choose, or?
That's a good question. So basically there's stages of rollouts of the slashing mechanism. It'll be fully live at the end of June, but effectively, at the moment, most of the deployed services are basically by design more like proof of authority. I mean, they function like proof of stake, but ultimately the stake wouldn't practically be slashed right now. But with the new slashing API, the way this works is there's like 3 levels. There's the consensus level events, which the system picks up and defines slashing conditions over. There's our framework level events, and then there's the application specific events. So the framework, which we've built around this consensus engine, we're using currently Tendermint, basically has its own slashing conditions. And then on top of that, you've got application specific ones. So in this case of the Oracle, you could define a condition where, for instance, if someone reports outlier observations all the time, or you could define arbitrary conditions in code which are relevant to the application, which then the application would, like as a whole, would enforce.
Cool.
And then if these conditions are met, then basically the rest of the system, the honest majority, will basically enforce those, right?
Yep. So they would, the service operator would set this up when he's setting up his contract. He would say like, you have to stake 10 ETH each, and it's going to be just straight Tendermint consensus for whether you get slashed.
Yeah, just nitpicking. It's called the service owner.
Service
basically,
owner, sorry.
Yeah. Because then we have the agent operator, which is the node operator. So the service owner, yes, they are defining all the terms about the service. So they define that in code. So on-chain, a service is represented as an NFT. And basically, you have your standard NFT with your image. That's just cute. So when you have it in your wallet, it looks nice. But you also in the same metadata, we introduced additional fields. One of them is called code URI, and that then resolves to the actual code. And then all the agents,
whole thing would be an NFT.
This whole thing would be an NFT, which references a field called code URI, which resolves off-chain into the actual code of the system. And so when I turn on an agent as an operator, basically all I do is I point it to that NFT.
So for people who are listening that don't know this, like in normal NFTs, it's what is it, like the meta URI?
Yeah, in a normal NFT, you have like name, description, attributes, and image. And we have that too. And then we add one more field.
Adding a field. And then, so this would be like in the Oracle example, this would be fetching the 5 APIs. And
so actually in all autonomous services, that specific field points to the service YAML. The service YAML, well, actually the wrapper around this is like basically a folder which contains mostly the service YAML. If you're a nice developer, also README and arbitrary code.
Okay.
And that service YAML is framework specific. So that will define the entire service, a bit like a matryoshka. So do you know what the Russian doll kind of thing?
No. Oh yeah. Okay.
Yeah. So like it's kind of just like this. So basically the service YAML then points to the agent specific code, and then that points to various configuration and code. So everything is defined like fully from the single hash, like all the configuration and all the code.
To like an IPFS agent or something, or or do you store it on IPFS, or where do you put it?
Exactly. It points to code which is stored on IPFS, which represents the code which makes up the agent, basically. Yeah.
Super cool. And then, yeah. Yeah, I feel like calling it an NFT is so it's like
Sorry?
it's like weird almost calling this an NFT.
Yeah, but you know why it's cool that it's an NFT. So what you now can do, like we'll have to come back to the example, but obviously you've got like all these kind of NFT marketplaces.
Right.
So now you can create basically servers on, like people can basically just create services and then sell them. So they can basically sell off-chain infrastructure to protocols, and protocols can on-chain own off-chain infrastructure. So your DAO's governance contract can own that NFT and thereby be its service owner. And we actually have this in the autonolas DAO. So the autonolas DAO governance contract directly controls a bunch of these NFTs, and they point to these off-chain services, and then the governance can turn them on and off again and upgrade them.
Okay, so I get that. So you could say like the service owner is, let's say your Rye stablecoin. You would own the NFT as the DAO, and then you would say like you have to stake our governance token in order to participate. And then when you stake our governance token, then you have to run this code, and we're allowed to update this code if we want to pick different exchanges.
Yep.
And then, no, super cool. And then the agents would basically, if they want to participate, they would go buy it, stake, and be able to run the code.
Yeah, exactly.
Okay, cool. No, I like it.
Glad you like it.
Yeah, I'm trying to think. It's very, like I think the first thing that would come to mind, like from a business perspective, is like, have you, we'll continue kind of on the governance cool tech setup, but like, have you found pushback from like users defining their own security? Like I know that's always such a hard thing for people to grasp. Like we've dealt with that with like the Oracle space. It's like, if you tell it like you can choose your own security, all the users are like, I just want a price feed, man.
Yeah. Actually, that's why we're not like we built the Oracle first, and then we're like, oh, this is actually not the market in which we should be. And there's like many reasons to this, like this, but also I think it's quite mature. Like there's like obviously dominant players. There's like different approaches. There's like a lot of brainpower has gone into this market, and we kind of came late, and you can do so many things on autonolas stack, which we're going to talk about. Like it just didn't seem worth our time to kind of focus on Oracle. So actually we have the Oracles as demos, but as I said, like no one's running them for production. What is running in production, which is a boring product as well, but it's very important, is keepers. So we have like the exact same setup, just that the agents do something different. And it's running on Keeper Network and doing work for like Connext, Yearn, and others, basically just executing Keeper jobs for them. So
well, would you even need to stake for a Keeper job, or probably?
Good question. Mostly not. But the basically what's interesting about Keeper Network, as we need to quickly understand what Keeper Network has this permissionless way of running keepers. So you have this primitive of a job, it lives in this job contract. And anyone in the vanilla case, there's some edge cases, but in the vanilla case, anyone can run off-chain code to work these jobs. Yeah, but you can see this is already like a race condition, like a gas war potential, right? Because basically, like people will want to work these jobs because then they kind of make a little bit of money. So basically what happens is that you have these inefficiencies in the keepers competing for these jobs. And that's, I mean, good for the person who's owning the job, right? But it's just really annoying for the keepers. But there's also the flip side of that, which is in such a model, there's no, like, it's an economic guarantee that there's someone working these, right? In like good economic conditions for the protocol, like people will find it worthwhile running a keeper and execute these jobs. But in a situation where maybe you're in a bear like now, or it's just like maybe no one knows about your job, like then no one runs it. So basically we work then with some partners in this ecosystem to bring an autonomous keeper service. And the benefit is that the agents in there, they are fully collaborative, right? They don't compete with each other. They function as a whole. And so whilst at any given moment in time, only one of them will obviously send the actual keeping transaction, the whole system owns effectively the returns of the system. And so that's why, even though on the job side we don't, yeah.
So for an example, like if it's a stable coin, back to the example, you would set up a keeper network that says if the collateral drops below a certain threshold, run liquidate, right?
Yeah. Yeah.
And you would want it. So like this job here would be like this would be like liquidate. And so usually the problem is that anybody's always allowed to run this function, but it's just like a gas race in terms of as soon as it's profitable, everyone's just going to be MEVing each other to death and getting all the profit. So what you do is you say the person who's allowed to run it is this service owner, and we're all going to monitor it and do it, and we'll all share in the liquidation.
So who's running it is the agents, right? The service owner is just the entity kind
well,
of.
he sets up like that's where like the funds of liquidation would go to, right?
Yeah, if you want to be specific, the funds, basically everything goes into a safe, like a multisig. And so it's kind of co-owned by everyone. And has the same, threat model, which we discussed earlier. So basically, if the honest majority behaves as it is implemented in code, then this whole system will work. And that's why you have like the slashing conditions as well.
So would they have to set up this job to be only able to be run by the service owner then?
Correct. That's a great question. So Connext, for instance, has done that. So they have a job live, which we have a priority on, like this, not we as in the service who is doing that. And basically the rationale there is exactly this Gaspos thing. So in the happy case, our service has the priority and that kind of does it, just does it. But let's say for whatever reason, the service doesn't do it, maybe it's faulty or whatever, you want to have a backup, right? So then like you can still, after some time, others can work it.
Yeah, because I mean, I would see here the problem if you didn't have that would be like one of these guys would monitor that, oh, it's time to submit. I'm just going to go submit on my own and get all the proceeds.
Yeah, but that's detectable by the others and then they'll be slashed, right?
Well, it might not be detectable by the others if he uses a different address.
Well, but then they can't because of the priority condition.
Yep, and then you would have to set up the priority condition in whatever smart contract this guy's running, right?
Yeah. So it's specific on that side.
Yep.
But for instance, Jörn hasn't set up that priority condition. Like what's actually an interesting takeaway from this, because when we were early, we thought, okay, because our system creates some overhead because of the off-chain communication, that we might not be very competitive. Turns out we're like super competitive. It's just because basically coming back to this other problem of keeper network, this kind of permissionlessness, is like you tend to have low effort by keepers to build good keepers, because like as long as you kind of run it, you run it. So we've built like this, cool system. So it kind of easily outcompetes, even if it has a bit more latency.
Right.
So we actually tend to do most of the jobs.
Yeah, no, that's cool. No, I could see. Yeah, I wonder if there's a way to set it up with like an Oracle service too, because like a lot of Oracles, like at least we have the decentralized Oracle piece, and there's a lot of it's just like MEV gas wars.
Yeah.
And so you could potentially set it up like this if you'd want to democratize it for some reason.
Yeah.
Like you said, the user probably doesn't care. It's just like better for all the keepers themselves. So.
And so like another one we can talk about, because it's actually quite a complementary example, is the one we're building with Cow at the moment. So we just, I think last week, got the governance Cow swap, yeah. Got the protocol vote through. Where basically they have like a lot of off-chain architecture, right? It's the protocol basically matches like these orders off-chain, and then sort of there are these solvers, and they compete for kind of solving for efficient outcomes. And apart from the solver stuff, as far as I understand, is pretty decentralized. But there's a couple of pieces of their off-chain architecture which kind of complements that. which aren't. And so we are now helping them build an autonomous service. Again, like basically just think of these 4 agents. It's just example, you can have many more.
Yes.
And they basically implement some of the logic which currently they run in a centralized way. So basically they're able then, in the first step, to just kind of get benefit of being able to have a distributed system with these fault tolerant guarantees. And then they can use their own token potentially to secure the system, right? And introduce community members as operators of the system. And so then the DAO, the DAO actually owns its own off-chain infrastructure. And this is really what we're excited about, because you effectively have like a lot of DAOs having these kind of off-chain things. They're like operational things, sometimes part of the product, which run quite centrally by maybe 1 or 2 team members. Maybe the on-chain representation of the DAO doesn't act, like the smart contracts don't even have any link or control over this. And so you bring back this control. You make it, like we say, actually autonomous, like bring back autonomy sort of.
So like in cow swap, we'll do it over here. They would have like buys and sells. This would be all off chain, I believe, right? And then, he wants to buy like 1, 2, 3, 4, 5, 6, and you have an order book that they have off chain, and then you would have these guys match them, right? Like,
so our guys don't actually match this. This is done by the solvers.
Okay.
They have like this order book, and then around this order book they have a bunch of other things which currently run centralized, which kind of make the whole cow swap experience actually work the way it works. Specific event monitoring from on-chain events, which then need to be fed into some API, which then becomes available to the solvers. So that sort of side part of things, which is very important to the functioning, is not currently decentralized, and this allows them to do that.
Cool. Yeah, no, I guess it's very sort of custom as far as so the security of it is very much based on how well you set up this contract right here, which is completely custom, right?
It's a good question. So actually, we are really happy that we build on the safe, because the safe is like this sort of this is like this amazing flywheel where people are building new stuff. So there's like all these modules now which you can add to a safe to basically
modules,
exactly, to constrain its functionality, right? Or like have more fine-grained access permissions. So we're in the process of doing this also for our autonomous service. So then you get 2 layers of like, basically I call it like the V1.5. So V1 was like just this off-chain consensus, and then once there's the multi-sig transaction, there's no further control. Like that's it. V1.5 is saying, okay, you've got this off-chain consensus, plus you have the on-chain guards to at least like limit which contracts you can interact with. And then V2 is all about verifiability of what happens off-chain. But we haven't built V2 yet.
Well, I mean, I know like for the Oracle example, it's really easy to say, like, if you made it like, you have to stake $100 in ETH, and then you're allowed to sign and be an Oracle reporter, and we're going to use it instantly with, there's like just no Sybil resistance. Anyone could, an ETH whale could come in and throw your Oracle price really, really easily, right? And
so yeah, I mean, two points on this. So firstly, like these systems, like it's not like you can enter and exit. Like there's like a kind of a process for people to come in and out.
So what's that process? Is that, I'm guessing, customizable?
Yes. Like right now, it's not as customizable as we would like it to be, but it is sufficiently customizable. The other thing is like eigenlayer, right? So you kind of, I think like there's pros and cons to that, but basically, like apart from the whole discussion which we also had yesterday and the days before with the kind of like basically the leverage it introduces into the system. What I wanted to get to is like for oracles, like some form of restaking, like extending security makes sense probably, because you kind of want that security of Ethereum, right? I'm not so sure whether it actually makes sense for a lot of applications, because I think it's a bit pretty like theoretical argument that all my DAO should have that level of security. I think practically it's often much more useful if it's proportional security. So think about like the keeper system again. If I'm a DAO which has like a market cap of billions, and my keeper network I'm relying on has a market cap of low 100 millions or less than that, is that really a good setup? Because like basically I could yeah. And so here you basically bring in proportionality. So basically here, if like I don't actually know whether Cow protocol will use their token to secure it, but like let's assume for the moment they would, then basically security of that protocol would be proportional to, you know, I guess the value of the cow's ecosystem, right? Which seems sort of not like a stupid thing. But I mean I wouldn't necessarily say I'm right on all these things. I'm just throwing out ideas.
No, I mean, like for most protocols, like whether it's cow swap or a lot of these, you know, like if you are DAOifying, like if your DAO can break your protocol, you should feel fine letting your DAO break your protocol in another way.
Yeah.
You know, like
exactly.
it's like there's no extra trust assumption there, I guess you would say. But if you're trying to, you know, say be completely like there is no DAO, there is no way for, you know, those token holders to do it, then maybe you could be adding risk if you add in voting.
Yeah, I agree. So, yeah,
you know, but so it definitely would make sense, and yeah, we'll just but the pieces of cool. So yeah, I mean, where I guess we'll get into the fun one. Where does AI fit in? What's where do we go?
So basically there's a couple of ways. So we're going to talk about an application, but just kind of a general motivational thing. So firstly, I'm just not so much a believer of trying to do too much ML on chain. I mean, I think that kind of has been largely refuted. I mean, there's a new way of doing ML on chain, which is zkML, but it's not quite the same because you're kind of constructing a lot of it off chain and then you're kind of verifying on chain. And, you know, we should definitely explore that and do more of that. And like, I'm all for it. But even with like forms of zkML, like ultimately, it is never just like, we were talking about oracles all the time. It's never just about the compute. It's also about the inputs. And like, if I have a system, like a zkML system, like then I still have the question of the inputs, like, can I trust those, right? And so like having a node system off chain, which kind of aggregates information from decentralized data points and kind of does things on like sanity checks on that or whatever, is even valuable if you have like very advanced on-chain ML functionality. So I just wanted to say that before I kind of get into what you can do on our stack, because sometimes people say, why don't you just do it on chain? And like, that's an argument against like why that isn't enough. I think I lost you.
Here?
Oh, you're back.
No, I'm okay. Can you hear me better? Best.
All good.
Yeah, no, I'm just gonna talk louder now. My wireless mic crapped out on me.
All right.
No, I think yeah, so like when you say machine learning though, like what does that mean? Because you know, I think to break down what you were saying, like sometimes, you know, like what are the inputs as far as like if you have usually machine learning or AI is done on these very, very large data sets, which you obviously can't store on chain. So then how do you even begin to sort of parse them or do it if you have this giant trust assumption about who's holding the data?
Yeah, okay. So there's this other important separation, training and inference. So if we train a model, again, like I just am not very bullish on doing that in a decentralized way. I think there's like specific subsets of models which lend themselves well. We just yesterday had a conference and there were like some experts talking about this. I'm not quite the expert there, but there's specific subsets which appear to be useful for decentralized training. But like, let's say like the common example, like an LLM, like it's nuts to think that you will train that in a decentralized way, because like they build supercomputers with like gigabit per second, you know, throughput between the components, and like shared memory is massive. Like forget about it. But what you like, then there's the fact, okay, so we can either have smaller models. So even an LLM, you could fine tune it, and then it becomes interesting, right? The fine tuning. So you could say, okay, we have this sort of, you know, foundational model over here. It's been trained by some centralized organization, although there's even like something like Together, which does it in a somewhat decentralized way. I mean, they basically have these compute classes and they split it up, so it's kind of like that. You could use one of those foundational models, and then with relatively little data, fine-tune a model. And this could be very, and has been shown to be interesting for DAOs, because basically a lot of people played around with, like, I think Jörn had one, other DAOs where you basically like feed it your entire documentation, and then people can sort of interact with the model specifically on like your DAO. You can do this in a crude way where it's just part of the prompt, and you can actually fine tune the model a bit on that. So that's interesting. But then also, let's get back to our use cases. We like fundamentally, I think right now with AI, it's just good to take what's there and integrate it, and don't try to be too innovative around the technologies, because like the people who've been working on these are like way ahead. So at the crypto AI intersection, it's all about, you know, adding that, like saying, okay, where can we add value? Like what are use cases where we can generally like address a pain point? So 2 examples. One is the governator, which we launched. So yeah. So you know already, it's hinting at the Terminator. And basically, we had the idea with my co-founder at ETH Denver. It's like you basically have an off-chain autonomous service, basically acting as a delegate. So like the Oracle over here, these agents control a safe, and basically people can delegate their token to the safe, right? If I want to be a human delegate, I can also say people, oh, delegate to the safe address, and then I'll be your delegate. Same thing here. But now there's no human. There's this off-chain autonomous system, and whenever proposals come live for those tokens where the governator holds tokens, it will go and read them. And when the people delegated, they also specified a preference. We are being super crude here. It's just good and evil. That's obviously like not the long-term goal, but right now that's it. So then we take these aggregate preferences, we take the proposal, or the system does that autonomously, and then it evaluates that together using an LLM to determine whether it should vote for, against, or abstain. And basically, once it has its voting intent, it will go and vote. And because you have effectively more than one agent, you can also create like sanity checks, right? So you don't just rely on that one eval. Like you can have multiple, and then you can kind of aggregate, and you can see, do you have outliers, and correct for that. So that's the governator.
Yeah, I mean, that's like, I guess you would just have to, because like our LLMs aren't deterministic right now, right?
No.
Yeah. So it would be really hard to fact check if somebody's lying, right?
Yes. But I mean, what does lying even mean here? I mean,
What do you know, if you just like, if you ask ChatGPT, is it good or evil? You know, like I could write evil. Like, how on earth do you tell, was that a good response or a bad response? I don't know.
Exactly. And so that's why it comes in handy. And it's a bit like with the Oracle example. You ultimately can never know whether any given observation was good or evil. Like, was it good intent and it's like a massive outlier because something was wrong there, or is it actually their price or whatever? Like, you just have to take it. And so you basically, what you do is, right, with the oracles, you just get lots of observation, you aggregate. That's what we do here as well.
Okay, so you just are assuming though that those guys are running the code at ChatGPT and not just writing the word evil?
Well, Yes, yeah. Basically, you have the same trust model. It's
Yeah, completely.
honest majority. You're basically saying like 2/3 plus one of the agents operating the code as worshipped. Yeah.
Yeah. Okay.
But again, I have to say, like people overthink this. Like if you compare it against the as is, right? So the way the system actually works, like the as is someone has to go and vote, and you will only know how they vote your delegate once they voted. I mean, they could write it on Twitter, but that's it. Here, the system can like basically say, I'm gonna be going to vote like this, and you could exit it. And if users really care, you could create it so that the system actually already voted, but didn't actually vote through to the end, so to speak. Like it creates a transaction with the vote, and then it gets executed by, let's say, the keeper later. So people could still exit their vote share.
Right.
You could do all sorts of cool things to make this better. And like, I think it just has to be driven by the user. Like so far, basically the question was, when can this be on Snapshot? So that's now what we're working on. The other cool example, just want to squeeze that in because it's super exciting, is one which like we're developing with like a lot of people in the Gnosis ecosystem. And basically it's called AI Max. I think when we met at the hackathon, actually, that's when we hacked that.
What is it? What?
AI Max, like MECH. Yeah.
Cool.
So I want to talk about the user journey before we get into the terminology, because that terminology is one mouthful.
I love the naming though. It's good.
Yeah. The user journey is such that you have people running Robo GPT, Auto GPT, Baby AGI, LangChain, all these autonomous agent systems now. And basically, if are you familiar with them? Otherwise, I can quickly
explain. I know these words.
Yeah. So basically, you give them a whole bunch of API keys, like some specific, Google API keys, some specific API key for OpenAI, Claude, all sorts of things which you want that tool to be able to access. You then give it sort of an open-ended task, and then it will go away and do this sort of chain of thought or other kind of ways of kind of working out the thing. So rather than ChatGPT, where you will send one prompt and it'll come back with one response, this system will somewhat semi-autonomously for some time go and work on this task. So you could, for instance, say research like the places where I could go on holiday with this budget at that time of the year, right? Now, if you go to ChatGPT, it's just not as exciting because it will basically give you these hypotheticals, and then you're like back to square one, because now you've got to go and check, are these prices like that?
Right.
Is there availability? And if like AutoGPT, at least in principle, has the ability to get that done. There's a lot of divergence issues, like where basically the system ends up doing something useless. And so there are no panacea. But like people are excited about this. So I think I might be totally wrong here, but like AutoGPT was one of the fastest or the fastest ever growing GitHub repo or something like crazy. It had like a lot of stars within no time. And basically just because like these kind of baby AGI ideas, like, you have the system working for you. It's exciting for people. And this is like totally in the sort of AI space. And what the obvious pain point here is, and kind of credit to Martin Koppelman, who kind of identified this, not I, and kind of motivated us there to work, is that basically you've got to bring all these API keys, right? So now you're like in this process of having to be like signing up to this, putting your credit card down there, and then you have like these 10 subscription to things and forget about canceling them and whatnot. And it's just like high friction. So what is the answer? Well, crypto, right? So you kind of just give it your wallet and off it goes. But how does this work? So basically AI Max basically creates a backend for that to work. So it enables an end user to go to ultimately RoboGPT or AutoGPT, give it its crypto wallet, and that's it. No API keys needed.
Well, I mean, and what would happen is these guys would get a bunch of API keys, right? Yeah.
And these guys will have subscriptions, and these guys will basically proxy the responses. And so you know, here, like we're totally obviously outside, like we're currently not worrying about, you know, is this verifiable? Is this like secure under all conditions? No, it's not. Like it's clearly not. But that isn't actually so much the point right now, because like a lot of interesting innovation can happen here, and like you basically just kind of trust that system at the moment. And the real unlock here is the ability crypto gives you in like payments and like simplifying the UX. And this is actually like crazy, right? Because usually crypto complicates the UX, but here it does the opposite.
Yeah, I mean, I would just question too, like, what would be the legality of it? I mean, as far as like, you know, like it would obviously be illegal, like you're like, I want to watch this show on Netflix, but I don't want to go to the API key. Can I just go, you know, can I just send you some crypto and then you stream me the Netflix show? Or, you know, like then you have access to Netflix, Hulu.
That depends. Yeah.
Yeah.
The answer depends on the service. So for instance, like a lot of these services obviously are already used by other applications. So if you like log into some other application under the hood, they'll use OpenAI. So as long as you fulfill the terms of service. So for instance, the way we actually operate this is with a moderation endpoint, so that, you know, if there's a query which is against the terms of service, we don't accept it. Sometimes it's quite centralized. But what's exciting is the underlying substrate is permissionless. So the way we see this grow is that you have basically AI Mech is like this permissionless hyperstructure where it just provides a marketplace where these off-chain AI systems can go to tap into other off-chain AI tools. And all they need is one crypto wallet. Right. And obviously we're like super at the beginning, but if we like get this right, then you can see like the value of that flywheel, because effectively you just like completely do away with like this kind of walls which you have in like accessing all these different services. You just like have your wallet, and your autonomous system will be able to consume like a multitude of services from a multitude of operators with very different backends, you know, open source, closed source, all sorts of things. So pretty excited about that.
Cool. Yeah, no, I just made it bigger so people can get a picture if you want to see the end result of the board. But so I guess, yeah, you know, to kind of wrap up, I guess where do you've kind of already talked where you see kind of the future going. What were some of the sort of assumptions that you had that sort of fell through when you were making this? Like how has your vision of oracles and off-chain stuff changed over the past year?
A lot. I mean, basically, we thought that, you know, we're like kind of, we spoke to a lot of DAOs, and they were like all talking about their problems with like off-chain and like decentralized things and stuff. So we're like, okay, well, we'll solve them for you. But actually, like, it's not enough to have the tech, and it was just like so hard to get adoption. So like basically it just takes forever. Everything takes long. Like even the DAOs with the best intention, they just take forever to get any change done, right? Like they're already struggling with like their core products, they're struggling with the bear, and then like kind of doing like infrastructure upgrades is like not necessarily like highest on the agenda, even if like in some spiritual sense it's highest on the agenda, in practical sense not. So you kind of did three things in response. One is like really thought hard about what drives buyer decisions, which is like around using the governance token. That's why we kind of added that opportunity to use that as the staking medium. And then like on the side which we control is like we focus on like two types of like applications on top of our stack. One with these kind of AI enabled processes where you know some part of it is some AI program. And the other is like a coordination product. So my co-founders are like very, very focused on that. It's called Centos. I didn't talk about it at all, but it's actually one of our most exciting products. And it has, but basically we call it Copilot for DAOs. It's very early days, but you can try it out. And it basically, I think, autonomously tweets. You can autonomously basically co-create content in it, and then it will sort of autonomously act upon that content on Twitter or Orbis or other social platforms.
Cool. And how do you pay the guys to do that? Like if I had a DAO, is it expensive for me to get you guys to tweet on my behalf?
So the Centos product currently is totally free, but it will like, that's because we're in a launch phase. It will ultimately have like sort of a micropayment approach probably, like where you basically, you know, provide a gas pool or something.
And can you like, what is a tweet about? Can you do like edgy, spicy memes?
Yeah. Well,
You set the level when you're
yeah, you set the level. I mean, you got to talk to my co-founder. It's so there's all these different Centos, it's like these little groups basically. And the last time I looked, there were like 10 or 15, and they're like very different, like some very protocol specific and some like taking the mic. So yeah.
I'll look at that. That'll be fun.
Yeah, check it out.
Or so, and it's all like AI generated?
Well, so it's co-created. So basically humans, like members of a DAO, or like something which might one day be a DAO, provide content, and they can provide their own or like text or whatever. That creates some sort of memory of the centaur. And then the AI part is that the actions which you want the system to take, you can define on a high level. And then when it comes the time to take these actions, the system will take this memory to kind of inform how it takes these actions.
Right. Cool. All right. Yeah, anything I missed real fast, or I'm guessing you just said a new product, so there's a whole lot here.
No, I just like, let me say the thing which I said at the beginning. I think DAOs, like the way we think about DAOs is a lot of them aren't very decentralized, a lot of them aren't very autonomous, and like it's not because people aren't trying. In some cases definitely is, but like in the good cases it's not because people aren't trying. I think DAOs are basically the primal form of co-owned AIs. And what I mean by this is DAOs in some form or another always have some processes of software, like be it the smart contracts or mostly also off-chain processes. And as we will see the evolution of DAOs, what I think will happen is that they'll become much more like full-on AI systems where the humans, at least for the protocol like DAOs, where the humans are basically at the edges kind of steering it through governance. And I think that's very exciting. And that's what autonolas is about. Definitely.
Yeah, well, where can people go to find out more? What's your Twitter?
Well, autonolas is the handle for the autonolas Twitter. My own one is, good question, David_ENIM.
All right. And your website is autonolas.network. Network.
Yeah.
Well, thank you so much. This was super cool. Definitely doing more AI stuff.
Okay, cool. See you.